Hey guys, so this video is going to pick up where we left off right before spring break. The title of this video is called Plate Tectonics. So when we last talked, Alfred Wegener was a gentleman who had given the scientific community pieces of evidence to say that the continents were at one point in time all stuck together and then they have since drifted apart. When we left him, he had presented this to the scientific community and they asked him, well, how do you know? And poor Wegener said, I have no idea. I just know what the evidence is telling me. And the scientific community refused to believe his actual ideas. So fast forward to the 1960s, and we come in contact with a guy by the name of Hess. He was a geologist, and he was also a Navy submarine commander, so he spent a lot of time close to the ocean floor. And he started to notice that there were several pieces of evidence that added up, and when you took Wegener's information and added that together, he figured out the how. So let's take a look at that. So Hess is responsible for an idea called seafloor spreading, and what you see here is a pool of magma comes up through a crack in the crust and it cools, and when it does so, it pushes the rock that's already there to the side. The continents are sitting on top of what we call plates, or lithospheric plates or tectonic plates. And so consequently, those continents are going to move as the plates are moving. Well, how do the plates move and how does the seafloor come up and the magma come up to cool? Well, this picture is showing you the lithosphere, which is the crust, and then the mantle that's directly underneath it. And the mantle, remember, has a different density. The hotter stuff is going to rise up to the top of the mantle and the cooler stuff is going to fall down. And we end up getting these convection cells. Well, the continuous convection cells are going to be the driving force to push the magma up through that crack in the crust, which then pushes the plates aside. This is an actual satellite image of what we know now as the Mid-Atlantic Ridge. Where that little dot is, that's where two plates have come together, the North American plate and the Eurasian plate. And they are currently pulling apart from each other because the magma and the sea floor is spreading apart. So there are three kinds of plate movements if we've got all of this stuff going on. The plates can have tension movement, or they're pulling away from each other. The plates can also have what we call compression movement, which is pushing up against each other. And they can have shear movement, sliding past each other. And I've given you three diagrams down at the bottom. Pause the video and record this in your notebook. So once these plates have the three different kinds of movement, we end up having boundaries, or areas where two plates are going to meet together. If the two plates are pulling apart, they are called a divergent plate boundary. If the two plates are pushing together or colliding, we call that a convergent plate boundary. And I've made a note for you that the density of the plate determines what happens when it actually collides. The third kind of plate boundary deals with the shear plate movement, where they slip past each other in opposite directions, and those are called transform plate boundaries. We'll talk a lot more this week about plate boundaries, and you'll get a little bit more specifics as far as where they're located and what kinds of features they create. We have three major categories of what we call crustal features. Some of our plates are underneath the ocean on the ocean floor. So we could create things like mid-ocean ridges, which I showed you, trenches, seamounts, which are underwater mountain ranges, and then volcanic island chains. Some of our crustal features are going to be found on land. We either get volcanic mountain ranges or continental mountain ranges. We also can get something called a hot spot, which is basically like a hole in the crust that as the plate moves over, it pushes the magma upward, creating an island chain. This is how the Hawaiian Islands came into existence. Likewise, we have two types of forces that are actually going to shape these crustal features. We have constructive forces that build up the Earth's crust, and we have destructive forces that wear away the crust. And all of these forces are going to follow Newton's laws of motion. We'll talk more about that later on this week. And ladies and gentlemen, that's a wrap.